It's we're live. Right. Right. Okay. Oh, what's this? So yesterday I did try to send some messages, and just as I was closing the stream, no, actually I was looking up. I was watching another Wayland video, and I realized that my header was wrong. So I'm gonna fix the header first, and then what I want to do is clean up. Yeah, do some refactoring, because I think it follows a lot of the same patterns between methods within Wayland. Once that's done, well, I mean, we'll say we'll get there first. But that'll be today's goal, which is not too bad. Right. I think first of all, gotta fix the header. Oh yeah, because message does contain header. So this will be size of message. Although I'm not sure if that's enough. So we'll run. Oh, okay. We do get something back, but it's all interesting. Something here, and then oh, 16. Let me get rid of the rest. Message bytes. Yeah, this is fine. That's what I sent. And send, don't need that. Whoa. I think it returns how many bytes you sent. Oh. I think I can just debug set send bytes. Message by message. Why do I have bytes? Make it message. Message sent. Message.len is equal to send. Send len. Okay, well that's what I get. Maybe what if I made this bigger? 0, 4. Interesting. I think it's just all just default values. So the send is probably not correct. What am I sending? Message. where M is header. I think this can just be size of message. Don't need this. Where did I get the object ID? I think from here. The opcode. Let me check the book again. Wayland header. Every message is an event. In the case of server to client messages or request client to server, which acts upon an object. The message header is two words. The first word is vectored object ID. The second is 16-bit values. The upper 16-bit is the size of the message. The lower 16 bits are the event or request opcode. The message arguments follow based on message signature agreed upon once by both parties. But actually, I need to specify header op and size. I am missing something. Recipient looks up the object ID's interface and the event or request defined by its opcode and determines signature and nature of the message. Display, is it display? Get registry. There's an argument registry of type new ID. Oh, okay. WL ID, WL registry takes name and ID. Interesting. What does this mean? New ID, global registry object. This is bind. Am I missing something here? Let me have a look at the example. Get registry. This size is 0, messages narrative 128 U8. Write to buffer message, size of message. Wayland display object ID, which is 1. Right. And then display. I think maybe I used the wrong opcode. I just use it as 1. Okay, then you write the opcode. The third argument is the size. U16, yes. Header size plus size of Wayland current ID. Yep, that's correct. New ID is a U32, which is part of message. Current ID is incremented. I think I went down too much. I want to check if my socket stuff is correct. Get environment, socket, AF Unix socket stream, 0. Now, one thing I'm not sure, are these the same things? Excuse me. Internet domain sockets by socketd has not previously bound to any address. The cost of domain. Zig connect sockets. Yep, I think TCP would do. It IP, maybe no. Maybe I should look up socket. Socket programming in Zig. It's a video. Maybe there's a transcript. No. Zig For Zig socket. What if I don't want to streaming sub? Okay, I think I just have to look. Yeah. Wonder if there's a way to find out. Socket 2. If Unix page 7. Local communication. Yep, sounds right. Can also use AF local. So if I do Unix 7. Okay, yeah. Being processed on the same machine efficiently. Traditionally, Unix domain sockets can be either named or bound to a file system path name, marked as being this type socket. Hey, Etheric. Abstract namespace. Valid socket types in the Unix are sockstream, or a stream-oriented socket, sockdgram for a datagram oriented socket. Hey, Devin, yeah. It's the most Unix implementation. Sockets are always reliable and don't reorder datagrams. Unix domain datagram sockets are always reliable and don't reorder datagrams. For sequence packet socket, this is a connection oriented, preserves message boundaries and delivers messages in the order that they are sent. Okay, I mean, I think this is what I'm doing. Always thought, no, I don't. I live, well, I mean, I think quite far from the US. So that does seem right. Let me just check my address. Socket address. Path. No, not this one. Not this one either. Not that one. Actually, how do I know which one is which? All right, okay. FreeBSD. Here. Now go back. How do you know what time? Oh, okay, you can see the time here. Oh yeah, oh, actually I forgot. It's the new year. Totally forgot about that. Tomorrow. So, header. Unix domain socket. So am I using the wrong address? Because the path is a bit smaller. How's the debugger coming along? Well, I'm trying to get the window working, so not very far. I think it might take all of 2026 at this rate, at least. But I mean, it's okay. I'm in no hurry. I got distracted by writing a Wayland client. I have a feeling I'm using the wrong type. PC domain. How do I know which one's which? BSD, blah blah blah. FreeBSD. It should just be this one. So I need family and no, that is here. Okay. So I'm using the right one. So as far as I understand, this is the default value, and I'm okay with the defaults. Yeah. Okay. Unix local. So the address is correct. Just path. The socket is that also seems right. Currently into learning some good Odin. I kinda like it. Nice one. What are you liking about it? Yikes, spilled some coffee. Okay, that's better. But I'm guess the LS, I'm guessing LSP, isn't working good with the with VS Code. Partially worked with Z. Excuse me. Yeah, the LSPs, I don't know. I mean, I think VS Code usually worked well, right? Header, message. Okay, you like syntax. How you mark pointers? It's this easy to introduce new types plus functions. Nice. I find the more you program language, if you like it more, I think it's a good sign. I think the more I write Zig, the more I like it too. I do like Go, to be honest. I use it when I'm not streaming. But yeah, I'm glad you're enjoying Odin. Okay, what am I doing? I'll figure it out. Header, new ID. Is this right? mem.asbytes. Takes a pointer. Asbytes return type. Oh, it returns a pointer. For example, I have a int vector and a flow vector both defined inside the vector package. The vector package is allowed to export divide, which then can be referred to as divide int vector, divide float vector. Okay, but how does it know which divide to use? Int vector from vector package. Ah, okay, when you in your divide. Okay, gotcha. Oh, that's pretty cool. Right. So it does genetics differently, if I'm right. Could even abstract away vector union and okay, that's pretty cool. Like an interface where you can switch the union and then decide. Oh, okay. I think I've done it before. It's pretty cool. I think you can do the same in Zig as well. Oh, hang on. Did I just get a response? I did. I mean, it just worked. Why didn't it work before? Let's go. I think I have an example of it, but not on this machine. I think it's kind of how you do, what's it called? Interfaces in Zig. Or one way to do it. You can also use a vtable. I haven't used a vtable before. Okay, so I am able to get a response. I don't know what it means. Okay. How do I To understand the message, the client and server have to establish objects in the first place. Object ID 1 is pre-allocated as the Wayland display singleton. Can be used to bootstrap. In Zig, could you do type instantiation at comp time, like add a list T? Right, okay, which doesn't work in Odin. I'm not sure. Well, it would depend. Yeah. Well, I don't really know, to be honest. You can. I'd never check that. Let's try further. The next chapter goes over what an interface is, how requests and events work. How do I parse a response? Requests and events. The server can also send messages back to the client. There we go. So those are called events. These are requests. One event that the server can send regarding a WL surface is enter, which it sends when the surface is being displayed on a specific output. Scale factor, blah, 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 blah. Turns object ID, message, and output. Well, what are the sizes? Object ID, code, and message. Is this the response? Seems like it. So if I look at error, object ID code. Oh, okay, I see. No. Is it? Takes new ID. Don't understand the response types. Object ID is a U32. So that would be the object ID. But how do I know if it's an error or not? Wayland server error code. No, that's not what I want to know. I want to know what this means. Oh, and it also read the whole thing. Zero, zero. How do you check? Check Indianness. So display whether the system is little Indian or big Indian. Well, CPU. Byte order is little Indian. little endian. Okay, so that means endian. I think it's flipped, right? It's the other way around. Arranged as 4 bytes in memory. Okay, yeah, it is. Big endian is okay. So something 2, something 0, something 36, and something. I think I called get registry because it's the new ID. The request creates a registry object that allows the client to list and bind the global objects available from the compositor. Should be noted that the server-side resource consumed response to get register request can only be released when the client disconnects, not when client-side proxy is destroyed. Right. Therefore, clients should invoke get registry as infrequently as possible to avoid wasting memory. Can only be released when the client disconnects. So I'm guessing when you close the application, it disconnects. Maybe. High-level protocol. Also, I don't understand this XML thing. Wayland get installed XML. Protocol / Wayland. I'm guessing in the path. What was the path again? Zip and Wayland. No. XDG. XDG. Runtime there. Run user 1000. Protocol? No. There's no protocol here. Hang on. Wait, there might be. No, that's not it. Well, I guess that's just the socket. Wayland info. No. Core part of Wayland architecture is libwayland, an interprocess communication library that translates a protocol definition in XML to a C language API. Merely encodes and decodes Wayland messages. So that's what we're trying to do. Wayland does not restrict. So this is where the protocol is defined. How can I see what protocol is currently architecture, FAQ, documentation. Add in basic principles, code generation. What is code generation? The interfaces, requests, and events are defined in protocol / Wayland or XML. Where is protocol? Right, I think this bit I've already done. Interfaces, registry. Binds an object to the display. Do I bind? I'm guessing this. So, but this becomes the new. Not sure. Events provided by callback compositor. I don't think this is it. Wayland protocol XML. Okay. I don't think this is it. Or maybe it could be. No, it's not. Well, I think this looks more like it. Interface name is WL display. Yeah, this looks right. Gonna save this. Might need this later. Actually, don't need that. I should get rid of that too. Oh no, hang on. That's my client. Sorry. I thought if save that. Interface name is display, request name is sync, request is get registry. Okay, here we go. Event. So these are the. What about success? Description. Request creates a registry object that allows the client to list and bind global objects available from the compositor. It should be noted that the server-side resource is consumed in the response. Yep, I read this already. Arc name registry type new ID. Interface WL registry. I don't think that's the one I called. Arc name is callback. Type is new ID. Interface is callback. That is sync. Ah, interesting. Okay, I see how this goes. There's a single argument for get registry. So this is an event. Name is error. Event name delete ID. Acknowledge object ID deletion. This event is used when internally by the object ID management logic when a client deletes an object that it had created. Somehow it makes a little bit sense. How do we know that the returned object is an error? The error event is sent out when a fatal error has occurred. The object ID argument is the object where the error occurred, most often in response to a request to that object. The code identifies the error and is defined by the object interface. As such, each interface defines its own set of error codes. The message is a brief description of the error for debugging convenience. Okay, so I think I need a way to first of all parse the response. But so let's have const response is a struct. Has a buffer. Slice of view 8. I think there's like multiple sets of information here. Right. I think my guess is one of these should be the length of whatever the message is, and there's more. There should be more. Because this looks like one. And there's another one here. Where the big number ends, there's another one there. Okay. I do see a pattern. And this looks like another long, very long message. There's another one here. Okay. Does it have a header? Does it return the same header? Object ID or code size. Oh, hang on. What if I change my ID to 3? Oh, it's different. Weird. If I change it again. Okay, no. So I thought it was... Oh, I thought that was the object ID, but doesn't seem like it. And if I use 1? I don't know. Why is it different for 2, but the rest, they look kind of similar. So much shorter message when the ID is not 2. Alright, let's leave it at 2 because we can parse it. Excuse me. Alright. I think to parse it, I would need to know what... Oh, actually, I could have checked this. See runtime, creating a registry. Buff read. No. Alright, I'm gonna read this one more time. Wayland protocol works by issuing requests and events that act on objects. Each object has an interface which defines what requests and events are possible, and the signature of each. Let's consider an example interface, WL surface. Okay. So that's defined here. So let's find WL surface. What was it again? Consider an example interface. So interface equals WL surface. Outside of an argument, is there one? Oh, here. No, I thought that was it. Get subsurface. Maybe it's called get surface. No. Interface equals WL surface. Let's go to like the first one. Okay, create surface. Sounds okay. Signature of each. Let's consider an example interface, WL interface. Surface is a box or pixel that can be displayed on screen. One of the primitives we build things like application window out of. Excuse me. One of its requests sent from a client to the server is damage. All right, let's find damage. Okay, yep, there we go. There's a request called damage. Excuse me. Which the client uses to indicate that some part of the surface has changed and needs to be redrawn. Here's an annotated example of damage message on the wire. So we need to send object ID. Okay, this is the header, I'm guessing. Okay, yes, correct. Object ID is 10. Got opcode. It's little Indian. It's little Indian, not Indian. So opcode should come first, right? Yeah. And the message length 24. How you write 24? Oh, because maybe, well, let's assume it's 24. I believe you. And we send the X coordinate and the Y coordinate. Actually, I can also check damage. Okay. I think this bit I sort of understand. You send X, Y, width, and height. Correct. This is a snippet of a session. Why is it so loud? The surface was allocated earlier and assigned with me an ID of 10. Ah, interesting. Okay, so that's what we assign. We send it an ID. Create surface. And it takes a new ID. Okay. That makes sense. Understood. It looks up an object ID with ID 10, finds that it's a WL surface instance. Knowing this, it looks up the signature of the request with opcode 2. Opcode 2. How do you... How do you know what the opcode is? Request opcode. What was the request again? Damage. Request name is damage. Wayland request code. The stream broke down. Node low operation. Excuse me. Each object implements an interface and the requests include an opcode that identifies which method in the interface to invoke. What is the interface called? Request name is damage, attach, destroy. Ah, I did what? I think one of the videos that I watched, they mentioned something like this. So within the interface, damage is the third request within the WL interface. It's destroys first 0, attach is 1, and then damage is 2. Okay, that kind of makes sense. Maybe I should write this down. Code is the index of the request within the interface in the protocol XML. It knows to expect 4 integers as arguments. Yep, because that's this is defined in the interface. So now you get an event back when you make the damage request. Request, yes. The server can also send back messages to the client called events. One event that the server can send regarding WL surface is enter, which it sends when that surface is being displayed on a specific output. Here's an example of such a message. Object ID, message length, and event opcode. So when it sent me back, was it the object ID? So that's 32 bits. 2, that's the object ID that I sent. And then this is the opcode, that is 0. Did I send 0? I guess opcode of the object. And this is message length. Okay, so the header is the same. I can use the same type to parse the header. And I think message length includes the header length. It sends when the service is being displayed on. Here's an example of a message. The message references another object by its ID. Right. The WL output object, which the surface is being shown on, WL output surface is being shown on. The client receives this and dances to a similar tune as the server did. It looks up object 10, associates it with WL surface interface, and looks up the signature of the event corresponding to opcode 0. What is opcode 0? WL. What is the interface that is sent? Enter. Go to WL interface. Name equals WL surface. And it sent opcode 0. Oh no, that's the error. Destroy. Weird. Oh no, but did we send damage? Don't understand this bit. It looks up object 10. Is this the object that we created? Associates it with WL surface interface and looks up the signature of the event corresponding to opcode 0. I think if I understand this bit, the rest would make sense. Well, my guess is it might be the object ID that we created. Maybe. Decodes the rest of the message accordingly, looking up WL output with ID 5 as well. Don't understand that either. Alright, let me at least just pass the header. There is a header, but there's also a message. Okay, I have an idea. Let's call this request. And this would be when it comes to event is packed. Does it need to be packed? I don't think so. So it would have a header. What do you do with this? It's an object ID. Will it always be an event? Object ID, code, message. That's an error. Oh, it would depend based on the object ID. Interesting. I mean, it seems like the error is the easiest to parse. How do we know it's an error? Maybe object ID. Yeah, okay. Events. What about this? Let's just call it data. It'll just be a slice of view 8 for now. It'll just be part of the buffer. Okay, I think that sounds good enough. Parse. Parse response. What would you need? Nothing really. And I think you can return. It'll return an event. Parse header. So get header data. How do we get a struct from bytes? Get struct. Reader take struct. I mean, it should be easier, I guess, than that. Oh, I could just get them individually. Return event dot header equals header dot object ID equals buff of size of view32. I need buff itself be type response. It would need to like move the pointer forward as well. So I create another function. Let's call it consume self response and then byte size. Oh no, not byte length. Let's call it T type. But yeah, I think this will make it a byte. I mean, make it a U32. What's it called? Bytes as value. Given a pointer of array of bytes, returns a pointer to a value. Bytes as to value. Given a pointer of an array of bytes, returns a value of specified type backed by a copy of those bytes. So can I just take a type? Which is type. Turns type of t, but it's already a type. Jeez. Okay, I think I'm complicating it too much. Let's make it void for now. Self dot can I just consume the whole header? This would be bytes. Yeah. AAU size. Self dot buff would be equal to self dot buff of rest. I mean, that makes sense. Kinda. Standard dot mem dot bytes to value header self dot buff t any type turns t. So this can then be header equals header. Can this header? Apparently not. And then const self dot consume size of header. And then const data is self dot buff of 0 to header dot size. The header size includes the header. We already can -4 minus size of header. I don't know, that doesn't look right. Actually, just to move that here and self a buff of size of header to header dot size. Data. No, I think then I should consume header dot size. Header and message. If self dot of dot len less than, okay, header size equal to size of header less than header size, return null. So that means this can be header size. Maybe I rename this to event request size message size. Consume message size, so that will consume the header and all right, save a build. Oh, but I didn't call it. Read bytes. Response is equal to response dot buff equals buff of 0 to read bytes. While response dot we can call this an iterator. Event standard debug print any e. What's that now? Expected type. So this can be a pointer. I don't think that changes the type. Expected type Wayland client dot response iterator found a const pointer. How do you make it? Doesn't sound better. Yeah, it's the same thing. Does it need to be a pointer? Kind of does, because I do modify the buffer. How do I remove that const? Const struct pointer Zig. Actually, struct. Okay, it's still a const. How do I remove the const? Okay, I think that works. No, it doesn't. Why is it? Cast discards const qualifier. What if I don't want a const? Say struct, no const. Struct pointer. Hey, CPT Chica. I don't know if that's your name. Pointers in Zig. In Zig, when you see a pointer to a struct that is not marked as const, it allows you to modify the contents of the struct to that pointer. Yeah, that's what I need. How do I actually struct? I could just do a const cast, but I don't want to. I think there's a better way to do it. Structs namespace can be called without a dot product. Is there a struct with a method here? How is Zig treating you? Pretty well, actually. I mean, the more I write, the more I enjoy it. False field values. Fact struct. Oh, no. I want to understand why. Why is this a const pointer? Drag for the default values, default field values. Is there one where it takes a pointer? So two. Self is pointed to a right, so there we go. Oh, but right print value. Is it because no, that can't be it, can it? I'll make this. Yeah, okay. That's not it. I mean, it was worth a try. Const struct print value takes a pointer to a writer. And these. I mean, it is a lot slower than just writing const cast, but I think I would like to understand. Might save me some time later. No, these are all. Okay, this is back to the beginning. Zig struct. Vector algebra generic. I have a pointer p to a struct instance with field simply as p. I have a member function self, where self is this. There's an instance s for struct. So I can call the function simply as. Questions are. Dope works both struct and value and struct pointers transparently. Similarly, namespace functions also do the same, the right thing when invoked. You can write functions that take pointers. You don't need to reference PV pointer to access the structs field. So instead, if I do our self is this, does that make it a not const? Okay, it's still the same thing. Interesting. What happens now? Why did that work? Index out of bounds. Okay, but that's fine. That is weird. So they don't need a pointer. Interesting. Okay, but I can do a bounce check. Yeah. Header. And I can read the header. Data. If buff.len is less than header dot message size, return no. Okay. Maybe I can print this better. Is the header again. Object ID, opcode message. Object ID. opcode. Let's call it len d. E dot, what is e header dot object id, e dot header dot opcode message len, and then e dot data any. There you go, it's a lot better. What's that again? No field named message len. Message size. I'm surprised there was no, the LSP didn't catch it. Okay, so that's what I'm getting back. I get the object ID that I sent back. Opcode is 0, len is 36. That's the data. Don't know what that data means. I wonder if this is a string of some sort. And then that. I also would like to parse. I guess from the header, based on the object ID or opcode, I think object ID, you should be able to tell if there's an error. But I guess that's a problem for tomorrow. Parsing messages from Wayland. Well, why do you ask me that? I don't know. It seems like a good place to stop. Maybe. I don't know. It's the holidays. You know, I think you can be a bit lazy. I don't need this. Don't need that. Okay, I'll make some notes for tomorrow. Do. One is parse error events, get interface. Actually, there's a few things. Check. Does it always just return the object ID? Because somehow this looks a bit wrong to me. Maybe, I'm not sure, but I think I'll check that tomorrow. Get node interface. What do I need? Yeah. Okay. Get registry. So it should either return the registry which it does, which my guess is that's the object for the registry. Well, I'm not sure. Also, what makes me think that I call get registry? Oh, because I can. Oh yeah, actually, there's more things to do. Create get registry method. And this there. Okay, I think I'll do that tomorrow. But actually, I could. Maybe I can move that here now. Function get registry takes socket underscore t and then returns message slice of bytes. So slice of U8. I think it's called standard POS6. Yep. Maybe I do city8 void. It takes a buffer U8. So I can just read into that buffer. All of this. Yep. And move this here. I will just become buffer. Yep, and I think it needs returns usize. Or maybe I can add it too. This return. Return. And then I can just call this var buffer 24 U8 is undefined. Then response bytes equals try get registry take socket and event bytes. Okay, and I think this here, the header can be that. I think it's request. I think I should move this out of there because I think it depends on the interface that you call. So it should be local. Because if you look at the XML interface, no, request, they all have their specific args. Okay, so I think that makes sense. That's the header, that's the request, message, sent len. So that should still work. So we'll run. Okay. But I'm not sure if this is get registry. Code enum. Maybe. And then I think same the opcode. Actually, I could do this now. I have an idea. Const object. No, I think I need the type. So what I'm thinking is because here each sort of what's the name interface has, I wonder if this is display get registry. Object ID is 1. Why is this 1? If interface is 1, callback. Let me just check. Display object ID. I wonder if object ID is 1 indexed and opcodes are 0 indexed within the interface. So that means compositor should be, that's the first one. Interface registry should be 2. Callback would be 3. So registry. Is that an interface? It is. Yeah, I don't know how the object IDs are based so far. So I can call this display const. What's this called? Protocol. Prot. So what I was thinking is I could name so let's say this would be display. This would be of type maybe rot. I don't know. I'll figure this out. Protocol XML to upload, and what's the other one? Yeah, XML to some sort of type. Interface equals WL something, and then request equals get something something. Okay, I think now I'm gonna call it a day. That's pretty good. I'll do that tomorrow, because I think having like all these numbers doesn't make sense. Oh, I could do something like if maybe. I'm not sure yet. I think I'll figure that out tomorrow. Okay. Now I'm for sure. I think I'm done. Pretty happy with that. At least there's some progress, and I'm starting to understand it a bit better. All right, I'm gonna call it a day there. Hope you have a good day and enjoy your New Year's. And I'll see you tomorrow. See you, Devnin. Happy New Year. Bye.